All right. Well, hello, everyone. Thank you so much for joining us this afternoon. My name is Hannah Crapone. I'm the content marketing manager here at Certiport. We're so happy to have you joining us for our third IT Specialist Academy webinar today. Now, please note that the session is being recorded, so you will receive a link to the full recording after our presentation has finished. If you have any questions, feel free to drop those either in the Q&A or the chat feature of Zoom, and we'll make sure to have Nora address those following her presentation today. Now, today our topic is artificial intelligence, and we're so thrilled to have Nora Burkhauser join us to train us on how to teach AI in the classroom. Nora is a computer science teacher in the Magnet program at Montgomery Blair High School in Silver Springs, Maryland. She is the instructor for the University of Maryland AI for All Artificial Intelligence Summer Camp and the professional development facilitator for the Maryland Center for Computing Education. Nora has developed and presented professional development on teaching AI and machine learning to Maryland teachers from kindergarten through high school. Ms. Burkhauser lives in Montgomery County, Maryland, where she enjoys hiking, has 3 young adult children, and an old cat named Spaz. So without further ado, Nora, we will go ahead and pass it over to you.
Thank you so much, Anna. I had to put that in part about the cat because you might hear from her at some point during this
Well,
webinar.
I always feel like then I should introduce my daughter because she might try to make an appearance as well. So background noise is always welcome around here.
Great. Well, thank you. And let me go ahead actually start sharing that. Hello, everybody. I just to add a little bit to the bio is how I kind of found myself teaching AI. I'm originally a math teacher and switched over to teaching computer science about 10, 12 years ago. And I mean, just like you probably have, I heard about AI, but we always, heard about it in the news and things like that. I kind of thought it was like this far-reaching concept that you really couldn't start studying until you were in graduate school. And then I was doing professional development, helping out at the state level in Maryland, and I was offered to teach a summer camp on artificial intelligence. And I was like, whoa, hold on a second, really? And it was for high school kids. And I'm really glad I said yes. So I was a little bit nervous at first. I went online, tried to find all kinds of videos and lessons and start teaching myself. And I got bogged down in the math because most of the stuff a couple of years ago was very high level. But the camp was successful. The kids learned, I learned a heck of a lot. And since then, I've been trying to spread the love, spread the joy about teaching artificial intelligence, to all of our kids, all students, because this is something that is shaping their lives every day, something that they use every day. So the more you understand about it, the better it is. And also to spark interest and to get a more diverse number of people or device into AI and working with AI so that we can have AI that works for everybody. So if I could go ahead and get started. Just a quick outline of the things that I'm going to go over today is sort of in a way to demo just a tiny little peek of some of the lessons that I've done in regards to artificial intelligence and machine learning. So an introduction that uses these examples, as well as just a little bit of information about what is it and what is machine learning, some of the vocabulary. So it's kind of like a mix of that. But some other important topics that you want to incorporate with your kids, and that is the impact and the ethics of AI. And that's usually actually a fun thing to teach and something the kids usually get very interested in. Of course, careers in AI. And then I'd like to demo for you just 2 of the many tools that I've used in my classroom to help teach AI. And then just a smidgen of the resources that are out there to help you learn a little bit more about AI and to help you teach AI as well. So I like to call this the hello world. If anybody's a computer science teacher, you know what I'm talking about. The hello world of teaching AI. And that is, what is AI? What does it mean? So what I'm showing here on this slide is, this is actually from one of our professional development classes. And I've done this with my students as well, is giving a link to a Jamboard or just handing out sticky notes and having the kids, the students, jot down their definition and then posting them up and having the conversation. And even going a little bit further than this and just naming some things like, what do you know of that you have or that you use or you interact with every day that uses AI. As a matter of fact, I'd like to be a little interactive here. If anybody would like to unmute themselves or put into the chat an example of something that you know that you use that is good. Cell phone, exactly. That's what I ever tell everybody. It's like, what's in your pocket? Anything else? Social media, very good. Oh, yes, yes, awesome example. Anybody have something at home, an assistant at home that if I said the name right now might respond? Haha, exactly. I won't say that word or that one either. Yep, wonderful. Okay, so and that usually gets the kids talking a lot about the different ways that they are aware of that these things use AI. Another activity I like to do. Oh, vacuums and lawnmowers. What doesn't use AI these days, right? I just put a link into the chat to a Google form. If you folks could go ahead out there and answer the questions. Let me go back here. I'm going to have to change my screen and get over to the form. So this is, delving a little bit more into what can AI do? What is AI capable of? It's not showing up in chat. Let's see.
I can see it, Nora, but I think it's just the panelists. Let me drop it in so everyone can.
Okay. Oh, that's right. It says to host and panelists.
Yeah,
My apologies. I forgot to change it to everybody.
There we go.
Thank you so much.
Yeah.
Okay. Okay. So it's a Google form, and this can be done in other ways. I switched it to a Google form, of course, when COVID and we were teaching from home. You could also do this in person where you give your students 2 different colors of tickets and you have boxes throughout the room with these labels on them. And the different colored ticket is indicating whether they think who could do this better. I mean, who has the capability, a human or an AI? But what I like about the form, the Google form, is you have to pick an answer. So you have to make a choice, even though some of these might not be clear. So if we just go through and I don't know, don't look at my screen if you haven't answered yet, but I'm going to go through and answer a couple of my own, because at the end, we can see the results and we can have a conversation about this. Even every time I do this, I sort of change my answers as well sometimes. All right, so I'm going to hit submit. And now I can, and you can do this as well. You can click on see previous responses. Another thing I like about Google Forms. So, and this is where we can have a conversation with our students. And I like this first one because they might not know about Watson and Watson's introduction as AI to the general public. And that was playing Jeopardy. And Watson won and beat everybody. So that's a cool thing to bring up. Things like climbing a mountain. I mean, what did we pick? We picked AI. Actually, this is interesting. Usually the young students pick humans for this one because that also comes into the realm of robotics as well. So there is no clear, definite answer for that one, but you can have a conversation about it. Recognize faces, AI. This is becoming, and it's interesting, that's a controversial thing too, facial recognition. And I'm surprised everybody picked AI because there have been issues in the news recently about facial recognition. And this one always makes me feel happy when people choose that humans are better at feeling happy than AI. Interesting, okay. Oh, good, finding patterns in pictures. Believe it or not, there are things that AI can see that humans cannot. So that's why we generally do say that AI does better. All right, so as you can see, a nice way to start the conversation about AI and what it can and cannot do. Another interesting one, knowing when to cross the street, because you start talking about driverless cars. Isn't that the same technology we're talking about? Looking for obstacles and knowing whether to go forward or to stop, that type of thing. So, another conversation that you could have there as well. And making decisions when the goal isn't clear. And another one that you could come back to this later when you learn about different types of algorithms, because one of the types of algorithms that is out there is let's give the AI a bunch of data and let the AI figure it out. Okay, how are you going to put these into groups to make classifications without me telling you? So that's actually one of the jobs of AI, is making a decision when the goal isn't clear. I don't know what you're going to do with this, but figure something out. Okay, so like I said, I have used that in my classroom and it usually goes very well. So another type of background thing is the history and the fact that this whole concept of AI has been around for many, many decades, going back to the 1950s. Turing wrote about it. And as a matter of fact, I was in a computer team meeting and the kids were still talking about Alan Turing and his concepts. But it's only most recently that it has really become pervasive throughout our community. And that's because, for a lot of reasons, hardware, the improvements hardware, computing power, and the quantity of data, that we can get. So it has grown and it has actually deepened a lot as well. And in addition to that, it's just the fact that, I skipped some, no, that AI also comes in a lot of different flavors. It's not just artificial intelligence. And a lot of people use artificial intelligence in conjunction with machine learning, but they're really one inside the other. There is AI that's not machine learning. So that's what I'm talking about on this particular slide. Just a regular program that goes through a bunch of loops and has a bunch of if and else statements is a rules-based program. And some of those can be considered AI. So for example, navigation systems, finding the shortest route between 2 points is a classic search engine, and you don't necessarily need machine learning to do that. But on the other hand, and what more people talk about is this concept of machine learning, where we start with some data. I'm going to show you specifically some pre-labeled data so that we can train a model and then use that model to make a prediction or answer a question later on. That's what we mean by machine learning, is just come up with something to be able to answer a question. Excuse me. So in part of the resources I want to show you, there is a video. I'm going to show part of it to you. But the way I usually preface this is starting to use a terminology and the vocabulary that's associated with AI and machine learning. So for this particular movie, I'm not going to show the whole thing, but ask the kids to listen. Okay, when do they talk about data? Because you can't do machine learning or AI without data. And then once you have that data, what is it in that data that you want to use to train your model? And what algorithm, what methodology are you going to use in order to train that information? And the result of that is to come up with what's called a model. And that model is what's used to make the predictions. So I bolded those words a little bit and asked the kids to listen for them. This particular video is also good because it gives a lot of everyday real world examples of using machine learning to solve problems. So I'm gonna skip over here. And this part of the video is where it gets its title from. They're going to talk about pickles and how using AI can help solve a problem regarding pickles.
We wanted to make this an open source project so that everyone outside of Google could use the same system we're using inside Google. There are lots of people who made very, very creative uses of it without knowing a single bit of machine learning. So if they have the ideas, they don't need to do heavy lifting that we've already done. I saw a good example there. Somebody used to have a cat going around their house at the time. So they trained a model to identify whenever the cat was there, and they would turn the sprinklers on to scare the cat away. This elderly couple in Japan who ran a cucumber farm, and one of the big tasks is to sort cucumbers into like prickly ones, less prickly ones, straight ones, curved ones. It's actually a complicated task. So the wife would spend many hours a day sorting cucumbers. So the son picked up a computer vision model and was able to build a system to categorize cucumbers and sort them automatically. All the time wasted sorting cucumbers is just going to be used in much better ways.
387 million people with diabetes are at risk for diabetic retinopathy. It causes blindness. The way that you can find signs of diabetic retinopathy is by taking pictures of the back of the eye. but there's just simply not enough doctors, and it takes hours for an interpretation. So we trained an algorithm that can read the images right then and there. The algorithm can help the doctors get more people screened for the disease.
The more you see machine learning and the kinds of things it can do, the more you see opportunity for it to improve people's lives.
Okay, so just in that short snippet, there were at least 4 different examples of using AI to solve a problem, which is generally how I like to teach about artificial intelligence, getting the kids to learn different things. And then at the end, project-based learning, what kind of problems do you think that could be solved, and having the kids develop something that would solve a problem. Okay, so I'm going to take a couple minutes and just very briefly talk about machine learning and familiarizing you with some of the vocabulary that's associated with it. So we said machine learning is a subset of AI. Well, within machine learning, there are different types, right? There's what we call supervised learning, where I have data that's been collected and has been identified. So if you want to think like with image recognition, somebody has collected pictures and identified, well, this picture has cats in it, these pictures have dogs in it. So that's label data. And then using that to train the model so that when it sees a new picture, it can tell whether it's a cat or a dog. As opposed to something that's called unsupervised learning, which is where you take a whole bunch of data and you try to categorize it. And the model comes up with, okay, all these are this type of lily, and those are maybe some kind of petunia or whatever. So it's identifying different characteristics and able to apply labels to it. And then finally, a different type is called reinforcement. And the best analogy for that is like playing a game. So if you're playing a game, you go along and you do something and you lose a life or the game ends, you learn about that. So then you go back, you start from the beginning and you learn to avoid that thing. So positive and negative reinforcement to help you move toward the end goal of winning something. So I don't know everybody's background or familiarity, but this is just a very kind of top level diagram of what the innards are of machine learning. So I mentioned data. And within that data, we have these things called features. So for example, I was talking about flowers. There is one data set that has measurements of different type of irises, the sepal length and the petal length. So that's the features that were chosen for these flowers. And each item in there is also labeled with what type of iris it is. So that data is fed into an algorithm that loops. And what it does is it comes up with these numeric values to try to relate those features to those labels. And it calculates how good did we do? And that's an error. And if it takes that error and uses that error to get better weights until it finally has some weights numbers. And it says, here's your model. And by the way, I don't know if anybody's a math teacher has that background. It's an equation is all it comes down to. So all of this, the features, the data going in is numbers. It's just cranking through them. The weights are numbers, and the final model is, here are your coefficients for your model. And then that model gets put into a program like an app or a regular program, and you feed in new data. And it says, okay, based on this model, that's this type of iris versus that type of iris. So that top level is what an AI or machine learning algorithm is doing. So as far as the algorithm itself, there are a lot of different ones. And a lot of kids, like I'm teaching older kids now in an elective, and they just all want to do heavy duty machine learning. But I also like to teach about some of the basic or original, quote unquote, type algorithms. So, and it's cool because you can do these in a classroom with a lot of different age kids just to get this concept of an algorithm and the fact that, hey, this is also AI. So there's a little game we're going to play, and I'm going to show a grid of pictures of celebrities. Is it possible that 2 people want to volunteer to do this? One person will select a celebrity, but keep it to themselves. you probably played this game as a kid, and a second person will ask yes, no questions to try to figure out who is the secret celebrity that they chose. So Catherine says they are willing to participate. Anybody else, or I could ask the questions if we don't have another volunteer.
I could also ask the questions too, Nora.
Okay. All right, so let me go to this next screen. So Catherine, your job is to, without telling us, select one of these celebrities. And then Hannah's going to ask you yes or no questions to try to figure out who you have chosen. Tell us when you're ready. Okay.
She's saying she wants to be unmuted. Kathy, do you just want to drop into the chat? Let us know when you're ready and I'll ask questions and you can respond yes or no through the chat. Perfect.
Okay.
She's ready to go. Okay. All right. So I am going to ask my first question. Is the celebrity male? Yes.
Okay.
Okay. Is the celebrity from the United States?
I don't know if I know all the answers to that. I think
Okay,
so.
we think so. Okay, so let me go to my next layer of question then. Is the celebrity an actor? So you have some that aren't actors, yeah?
Correct.
Yeah. Could be putting Kathy on the spot too. Oh, no to the last question. So not from the United States, and then yes to an actor. Okay.
Okay.
Okay, let's see. I feel like it's a little early for me to guess, but I kind of feel
You
like
could try.
I could. Is it Shah Rukh? No. Okay, I'm still too far out. Okay, so no to being from the United States, yes to being an actor. Let's see. Gosh, I don't know. Okay, let me see if I can ask another question. Is the celebrity white? Yes. Okay. Is the celebrity Tom? Is that Tom Wellington? Yeah.
I honestly don't know.
I got it right.
Oh,
Perfect.
cool.
There
Excellent.
we
Thanks
go.
for your help.
Sure, machine could have done that way faster than me, but there you
Well,
go.
you don't know. Actually, you never know. So that childhood game is actually an algorithm that is used called a decision tree. And that first question, which was good because it's the first split. And normally when you're asking these yes, no questions, you want to say, okay, let me try to divide it as evenly as possible. Oh, Tom Holland, there you go. You want to divide it as even as possible. So usually gender is one good way to divide evenly, or a lot of folks might see race or something like that. Even some students have gone like top row, bottom row, which is probably more along the lines of the way an AI would work. So you have that first split, and then trying to look at the features, and there's that word again, the features, gender being one, race could be another. What you know about the person, in other words, whether they're an actor or not, are the subsequent questions, until you get to the point where you can classify, your final result. So, at a younger level, it would just be teaching the kids, hey, this is an algorithm type of thing. At the older level, I actually do get the kids to work with this algorithm in a program. Oh, good. I'll go back to that. So this is just the terminology for a decision tree. The nodes are the questions that you ask. And so they have a yes, no answer. So that would go to the next node. when it gets to, well, yeah, decision node. When it gets to a leaf node, that's when a classification is made. Okay. So the nodes make the branches. The leaves are the end of the branches where you actually have to put a label. So if this was me trying to figure out if I want to go out and play soccer one day based on the weather, you know, when it gets through to the bottom, it would be either, yeah, go play soccer, or no, stay inside and play video games. So there's a lot of activities available online to get the kids to do decision trees in a lot of different ways, things that they know about. So like I had mentioned, the iris flower, and this is for the older kids in the elective that I'm teaching, where they actually do pull in that data with the sepal and the petal length, and it's pre-labeled, and they don't code the algorithm itself. They use the algorithm because all this stuff has been programmed already and saved in programming libraries, but it's pretty cool where the kids, they learn how it works and then they apply it and then they can see it. The elective I'm teaching is just called Introduction to Artificial Intelligence. Okay, so that was just a quick overview about machine learning and some of the algorithms. Another important topic that I think should be in any time you're going to teach about AI is impact and ethics. Impact, well, they go together, because the AI, you want it to do good. That's impact, but there's negative impacts at times as well, and that brings up the ethical concerns. So what I have on here, and you know what, I should put, before I get out of here, I will put the link to my slides in the chat, because I have links in here for you if you want to go back and check them out. But there are so many examples online of the things that AI can do, and also so many examples online of the concerns that have to do with AI. So a classic one, and this goes back to the controversy of facial recognition. Well, no, not facial recognition, my apologies, about this one's deep fakes. A lot of folks are concerned about that. It's like, well, I've got this video of Barack Obama saying something that he never said. That's a classic deep fake. And so this website puts 2 pictures up, and you have to decide which of these pictures, one of them's a real person, the other was manufactured by a computer program. So, and the cool, scary thing, 4 years ago when this first was available, it was really easy because the AI had obvious mistakes. Like one eye would be, or the ear would be lopsided, or the hair would just be like out of focus. Now it's harder. I don't know if anybody wants to take a guess at which one of these 2 faces is real. I'm having a hard time with this one, but I'm going to guess the left is real. I was correct. Okay. All right. Like I said, it's so much harder now than it was before, because these algorithms are getting so much better than they used to be. This one is, to me, a little bit easier to tell just because of the lighting, and that I'm still thinking it's the woman on the left, and that is correct. And another tell that my students have noticed is the AI, like 99% of the times, will be looking at the camera, whereas the real person doesn't always look at the camera. So that's just one example of, the impact of AI. Just, I guess, basically seeing it in the wild and what it can do. And about the creativity of AI, there's actually a website where you can buy, and these are not NFTs, where you can buy art that was created by a machine learning algorithm. Yeah, I don't know that I would spend my money on that. I know an artist. She uses AI to create her art, and I know that happens a lot, which is different than just saying, just go make something. So yeah, everybody could probably have an opinion about that as well. And believe it or not, they asked an algorithm to write a screenplay, and then somebody went and made the video. It's hilarious. So little things like this can be fun as well. But on the ethics side, is the AI doing what we expect it to do? So this is a classic example where they wanted to train an AI to tell the difference between coyotes and wolves. And according to the folks working on it, it was working great until they found out it wasn't. That it hadn't trained on the animals at all. The training was on whether there was snow in the picture or not. So again, just examples too of why we need to have a lot of folks involved in creating these things and testing these things and making sure that they're doing the things that we expect that they're going to be doing. And I had very recently done a search online when I was teaching my kids, and we have a unit on ethics. And you can find things in the news today and what somebody's doing within an AI. So COVID, obviously, there's a lot of stuff out there. There's a lot of ways people were trying to use AI to improve the things that were going on in regards to COVID. And there were a lot of issues associated with it. So this is just a blurb out of an article. The AI wrongly learned to predict serious COVID because of a person's position, not because of what was being scanned. And another AI was only making determinations based on the text font that was being used and not the words that were in there. So just a lot of cautionary tales out there. There's a lot of tools, and there are oodles and oodles of resources in regards to impact and ethics of AI. One person that you really want to introduce is Joy Buolamwini, about bias in algorithms. And I'm sorry, I forget the name. There was actually a Netflix. It was on Netflix recently, movie about her work. MIT has a moral machine that has the kids go through and decide, okay, if you're driving a car and you either have to crash here or crash into these people, which would you do? And how do you want your car to make that decision? And impact as well on employment and hiring algorithms. There's a really cool tool, Survival of the Best Fit, that you can go through. And just a website that I found kind of speaks to the teenager. It's called In the Black Mirror. Conversations about the changes that are coming about because of AI. Another important topic also, careers in AI, because a lot of kids might think that, it's just coding. You're thinking just a hacker or whatever. It's not. As a matter of fact, when we do this camp in the summer, they have guest folks come in to talk to the kids. And more than half of them, their degree is not in computer science, not in data science or anything like that. As a matter of fact, a fair number of people like we're an English major or something like that. And you really need a variety of people to do all the jobs that are necessary to have AI that's going to work well. So on the screen here, these are just a few of the job titles, and these are more of the kind of technical ones too, right? But they don't all require necessarily using technology every single day. This is an area I'm still learning more about and need to incorporate more into my own lessons. And this is a slide I borrowed from somebody. We do PD, Introduction to AI, and there's another gentleman who talks about this because he actually is employed by a company that uses AI. So it talks about, the overlapping, how nobody knows it all. So you always have to have a team. So working in a team, of course, is going to be very important. Okay, so tools. There are two in particular, but there are tons more out there that you can use in the classroom to have the kids, even if it's just learning the terminology, not necessarily working through an entire big project, but just having exposure to all this. And one of them is machine learning for kids, and the other one is Google's Teachable Machine. So I actually have both of those open right now. Here. So machine learning for kids, it does require, if you want to save your project, it does require you setting up an API key with Watson Computer. The directions are provided for you. If you go into the teacher page, you can download the directions for everything you need to do. But you can actually run in here. You can come in here and you can create a project and test it without even logging in. So that's what's really cool. So you can use it a whole lot of different levels. So I do have a teacher account. So I do have saved projects, which is really good for now. And you can train on different things. As you can see here, I can do text, I can do images, train on numbers. And very quickly, I'll show you this one about text. So one of the areas of artificial intelligence is natural language processing. That is trying to figure out from the words, the sentiment. So for example, in the class that I'm teaching right now, the kids have a data set that is movie reviews, which has been translated all to numbers and also been labeled with whether it's a positive review or a negative review. And so they want to train a model that can tell in a new review whether it's a positive or negative review. So you can automatically know without having a human read the review what it's going to be. So you can come in here, and I've got this one, it's already set up. And I don't know if you remember me talking about labels. So my labels here are silly, family, pet, or neutral. So if I have a chatbot that I want to program and I want it to react to things that you're typing in, I need to know generally what is it you're saying without knowing exactly what you're saying. So this is my label data, and I'm going to teach kids. I have them usually work in a group so they can get more data in there, make it go a little bit faster. This is hardly enough data, but machine learning for kids will still let you train. So you can see, and I could even add more now if I wanted to, right? So after that task of putting in your labeled data, you go back to the project and you come in here and it says learn and test. And I already trained this, I already ran it, because sometimes it might take a couple of minutes, but this is already trained. So now I'm ready to test. So now I can type in some words here, and it's going to use its model and it's going to put a label on it to predict what I'm saying. So I want to say something like, so Spaz is my cat. Spaz is meowing at me. And it says neutral. And it also has a confidence level. So actually this kind of goes back to the game that we were playing about whether it was an actor or whether they're, lived in the United States or not. There's that whole, you had to pick yes or no, right? But you weren't confident. So same thing, that's exactly what's happening here. The model says, I think this is a neutral statement. I'm 53% confident. Turns out it's wrong. I'm actually talking about my cat. But it doesn't know that because it doesn't know Spaz is a cat. So let's just try another one. This rain makes me sad. Now it thinks I'm talking about my pet. So another great conversation we can have with the kids, and I usually ask them after creating a project like this to test it, what were the results? Why do you think you got those results? And they should come up with answers like, well, I just didn't have enough data. I didn't collect enough data for it to really truly recognize what I was talking about. And there are so many things you can do in here. If you go to the worksheets tab, well, in here are PDFs of step-by-step how to go through, how to train the model. And then if you want to pull it into either a Scratch program or a Python program, and then use it to actually build something. So it's pretty cool. It's a lot of fun, and I really like using it. There's another one, excuse me, a little bit easier to use, a little bit more accessible, and that's Google's Teachable Machine. You don't need an account at all. If you have a Google Drive account though, which is really cool, you can save your projects. So this particular project is one that I made months ago, and I was able to pull it up from my Google Drive. You can use your webcam. So I actually, when we were stay at home, had the kids create something in here, and a student used his webcam and was able to train on different types of sneakers that he had. So it's pretty cool. So I trained this one on different pictures of cats and dogs, because way back when, before COVID, when we were in the classroom, the kids on the desktop computers didn't have webcams, so we had to use pictures. So you put in them, you click on the training, and then you can test it. So as you can see, it has 100% confidence that this is a dog. I do have other pictures here though that I can pull up. I can get to them. All right, I have this other picture here, and it's at 100%, it's a cat. And now I have a picture of Baby Yoda, which is not a cat and not a dog, but the teachable machine has to pick a label. If anybody wants to put in the chat whether they think Baby Yoda is going to be classified as a cat or a dog. I have a vote for a cat. Let us see. Baby Yoda, 97% confident it's a dog. Usually always comes back that way, not sure why. So, and another good conversation. So that's not a cat or a dog, but you're forcing your AI to make a decision and to make a label. And that's even a pretty high confidence level. So, you know, things that you can have conversations about. All right. So I will share the link to the slides, like I said, and did I put links to these in there? Well, these are actually, you could just Google search and you'll find it very quickly. That's actually how I get there every time myself. All right, and as I was mentioning, I like to do project-based learning. The kids go in and they have, like they're told what project to make, you know, do a chat bot that can tell happy or sad. And after they learn the tool, then asking them, what is a problem that you think you could create a model that could be used to help? And some examples I usually give them, I live in Maryland. Maryland has 2 types of snakes that are poisonous. Most snakes out there are harmless. What if I wanted to point my phone at a picture of a snake and have it tell me whether it's poisonous or not? There's apps actually for a lot of these things now, but don't necessarily tell the kids that. I know there's one that will go outside and probably identify poison ivy now. And another one, I have students that take ASL. So I have an app that would recognize hand signals. And so a lot of really cool ideas. And the kids usually enjoy doing this as well. And then they do a presentation about it at the end as well. So my last 2 things, resources for you to learn about AI. I highly recommend MindSpark AI. This is, it's through IBM, and it is online classes that you take at your own leisure, and it's all free. And I don't remember how many there are right now, like 9 or 10 different modules, from very basic, hello world, what is AI, natural language processing, ethics of AI, so forth and so on. So those are really good. The professional development that I run for Maryland, we do half the teachers will do the MindSpark lessons and half we do in person, having them develop something for a lesson in their own classroom. Highly recommend AI for K-12. That's an organization, but they also have resources out there that is putting together a framework for how to teach AI kindergarten through 12th grade. So they're also, you know, keeping tabs on lots of good resources. Google has a lot of awesome websites. That's where I started when I wanted to learn about AI. And not only that, but they have AI experiments. Like, has anyone ever done Quick Draw? That's a fun one to do with kids, and that uses AI. And for higher level, Kaggle Intro to Machine Learning. So, you know, for the kids that already have that significant computer science and they want to delve into that, learning to, I think somebody mentioned in the chat about Google Colabs, that's what I use as well. And, you know, pulling in Kaggle data sets and being able to train models using those. And then for teaching AI, there are, just in the past 4 years, there is new stuff all the time. When I started teaching AI in my classroom, there really wasn't anything. So I developed my own unit for my introductory lesson. Somebody asked me what, oh, the grade level for the elective. Yeah, the elective is for 11th and 12th graders. But for 8th and 9th graders, I came up with a Foundations of Computer Science elective. Not elective, I'm sorry, it was just a unit. And code.org actually has one now that's almost exactly like mine. I don't know if they got the ideas from me or not. But I guess, you know, that introductory foundational course is pretty much the same, but code.org has a good one. AI for All has tons of lessons. So you could have bites of AI, you could do just a little bit, especially now at the end of the school year is a great time to pull these things in. Elements of AI I haven't used too much, but it's a lovely online kind of almost textbook about it. And I put Technovation up there, Curiosity Machine, because that's a neat program that when I first got into this, I ran it. It was for families to learn about AI. So I went to my library and said, hey, can I present this to the community? And they're like, well, sure. Didn't have a whole lot of environment. I think I ended up with just 3 families. But it was really cool to see the families working together to develop. They just have to work on ideas. They don't necessarily have to build anything. So I thought that was really cool as well. And that is my presentation. So I am going to grab the link to these slides and put it in the chat.
Thank you so, so much, Nora. And we are so grateful for you sharing your knowledge. We just had, I think, one major question that came through in reference to what grade level it is you currently teach at the moment. I don't know if you saw that one come through.
Well, I'm a high school teacher, and I actually am in a new school, and I'm teaching in a magnet program. So when I say AI elective, so these are actually the kids in the magnet program.
Mm-hmm.
But I think when I'm teaching now, the elective itself doesn't have, it should be for older kids, 11th and 12th grade. But at least if they've had AP computer science, I think they can do it, because the coding is not intricate. And I think, because it's the camp, I teach the kids at camp and they come in with no coding experience. So you could teach that elective, I think, but just probably better for the higher grade level kids.
So people are already trying to get into your
Oh, my apologies. I'm gonna fix that right now.
Okay, perfect.
I'm gonna change it to anybody with the link, so you won't have to send me an email.
And I will say, that's okay. That is totally fine. I will just say for anyone who's watching this in the recorded version, we will be emailing out the link that Nora has just dropped into the chat so that everyone can get access to these slides. Some absolutely amazing resources that you've mentioned, Nora. So we really appreciate you taking the time to share those with us. In wrapping up, I just wanted to say that we will also be having one additional session before we wrap up our month of IT specialist training. So we'll be having a session next week about computational thinking. So moving into this very idea about AI and machine learning and the importance of computational thinking in the classroom for your students. So I'm going to go ahead and drop the link into the chat. So anyone who's not registered for that can go ahead and do that. We hope that we get to see you next week at the same time. And again, thank you so much, Nora, for sharing your thoughts and expertise with us. We really appreciate it.
Oh, no, yes, you're welcome.
Okay. Thank you so much, everyone. Have a great rest of your afternoon.